is Griffiths E&M, section 1.1.4, talking about the position, displacement, and separation vectors. All right, so now that we've talked about vectors, we can go ahead and talk about the specific notation that we are going to use in this course. Oftentimes, we are going to want to care about particular points in space. So here's a point P. We have defined a coordinate system. Let's go ahead and use Cartesian coordinates here, x hat, y hat, and z hat. And from our origin, we have a vector that points from the origin to our point P. All right, and let's call that vector r. That vector r can be rewritten as a projection of the components, just like we did previously. So we can say that r is now x in the x hat plus y in the y hat plus z in the z hat. And we can calculate what the magnitude of that vector is, right? Vector r, magnitude, I can just rewrite that as r without an arrow over the top. And we know that that is equal to the sum of the square of all of the components, x squared plus y squared plus z squared. We can also define a unit vector that points in the direction of our vector r. I'm not going to draw it in a particular size, but I'm going to draw the orientation correctly. This is a unit vector, r hat, that points in the direction of r but has length 1. So to build that unit vector, we take our vector and divide it by the magnitude of that vector. Therefore, r hat becomes x in the x hat plus y in the y hat plus z in the z hat, all over x squared plus y squared plus z squared. All right, so we take a vector from a coordinate system, we can find the magnitude of that, and as a result, we can find the unit vector that points in the direction of the vector we originally cared about. And in many instances, we're going to need to keep track of multiple vectors within a problem. Okay? And it's important that we use the correct notation, otherwise it's going to be very confusing. So in many problems, we will have our coordinate system. Let's go ahead and say x hat, y hat, z hat. I'm just arbitrarily choosing this coordinate system, but that's okay. I am going to want to evaluate what the field looks like at some point in space, P. All right, I'll go ahead and use a red vector again for that. That's R. That's where we're evaluating what the field is. And that field is being generated by some, either a charge or a current, depending on what field we're talking about, that's in some other point in space. So there's another place that we need to keep track of. That is the source of our field. And by convention, we go ahead and call that vector r prime. All right, so r prime is associated with the source of the field, and r is associated with the location that we're measuring the field at. And then we also define another vector that points from the source to the observation that we call script r. Okay, and then script r is defined as r minus r prime. It is a vector that we add on to r prime that gives us r. That's the way I like to think about it. Okay. So what I find convenient to do is to take my components. Vector r is going to be x in the x hat plus y in the y hat plus z in the z hat. My vector r prime is going to be some other set of components in the same coordinate system. X prime in the x hat, y prime in the y hat, and z prime in the z hat. And then I can build my new vector, script r, since it's r minus r prime, that becomes x minus x prime in the x hat plus y minus y prime in the y hat plus z minus z prime in the z hat. And again, we can go ahead and calculate the magnitudes and also define script r hat, the unit vector. I won't do that here. All right. The reason it's so important to keep track of these different coordinate systems, or the different vectors within our coordinate system, is sometimes you'll have an integral that is over, let's say, the primed coordinates. And sometimes you'll have integrals that are over maybe the unprimed coordinates. And those are not equal. All right, so we need to make sure that we associate our primed coordinates with our sources of our field, and our unprimed coordinates has the observation point.